A blinking star is only a vague promise. And when have we sought comfort in the mystery of hope? So tell us, there is a way to transcend the elms and basswoods. Tell me about the lives at risk to capture their wondrous bellies. That they too are desperate for more than faded dots beyond reach.
We copy that, and preliminary ohms 241 plus 05.
Copy, Columbia.
Scientists hover around computer consoles and await the first image that will prove that Chandra is a revolutionary telescope.
Tell me that the first light is the sprinkling image of a star exploded from bearing our daily requests.
They will not be disappointed.
Astronomers worry about two very large questions. How does the universe work, and where did it come from? In this program, we consider both these questions on the nature and the origin of the universe.
We like to understand the things that are around us, to explain them. We don't like uncertainty and mystery. And the sky at night, you just have to look up there and you go, what are all those dots of light?
Humankind, we've always been discoverers, so we want to understand everything that surrounds us. Missions like Chandra provide an additional window into those questions.
It's very much this process of constant discovery and constantly moving those questions forward until you're asking things that you never expected to even be able to ask.
I have an 8-year-old, and she actually asks me about once a week, have we seen all the way back to the Big Bang yet? Why not? When are we going to do that? Mama, have you seen all the way back yet?
It was during a 1962 rocket flight led by an incredibly profound individual named Riccardo Giacconi. This rocket unknowingly detected these 9,000-year-old photons from this distant, incredibly bright, incredibly mysterious system that we didn't even know existed. And in that very moment, even though they didn't know it, they gave birth to the field of X-ray astronomy.
The primary scientific objective that was written down in the proposal for Chandra was to resolve the X-ray background.
They knew the science that they wanted to do. The technology to do it didn't actually exist. Countless engineers had to solve a whole host of problems to get Chandra on orbit. The mirrors on Chandra, those mirrors had to be smooth to the level of a couple of atoms. You're skipping photons, so they need to be atomically smooth. And they have to be really delicately aligned because you need all 8 mirrors to be working together, right? And they are now focusing on an instrument, and the instrument chips are only 4 inches square. And you have to hit that 4-inch square every single time. And that's not actually good enough. That would just give you a blob. So to get the imaging you want, the resolution you want, you have to hit exactly the same spot on that 4-inch square every time. And the spot you have to hit is less than the diameter of a human hair, 10 meters away. Then you have to do this on Earth, but it's going to operate in 0G. So you need to figure out how can I align these so that they'll be aligned on Earth for testing, but then when it's up in space, it has to stay aligned. You can't go up and fix it. So how do I build all the structure around it so that they stay aligned so precisely through all of that? So once you've done that, you have to make sure that you're controlling the temperature of those mirrors to within fractions of a degree. But you're in space. It's a harsh environment. The engineering and the level of testing and trying and retrying and testing to get just the mirrors right is absolutely mind-blowing.
And those mirrors, they are absolutely the most pristine X-ray mirrors ever flown, and they give Chandra its incredible power.
Less than 1 minute away now from the 95th Space Shuttle launch. 35 seconds. T-minus 30 seconds.
When Chandra went up on the shuttle, so the shuttle basically lit up the sky like daylight for a couple of minutes as it went up, and the ground underneath our feet shook.
5, 4, 3. We have a go for engine start. 0. We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
And we were 2 or 3 miles away. So it's just an amazing feeling of the power that is needed to escape the Earth's gravitational pull, which we needed to do to get in orbit. And also amazing to think that mankind can actually do this. It's very satisfying and exciting to see the results of all the years and all the people who've worked on Chandra, and finally it goes up.
It was the largest payload the space shuttle had ever launched. There were inherent risks in that launch to the crew, specifically. And when we talked to Eileen Collins, who was the woman that commanded the NASA space mission, she talks about them and just very calmly tells us how much they trained for any of those contingency plans, that they had total faith in the operators and the mission control engineers and the flight crew, that they felt they knew this stuff in and out and they could get it done. And they did, literally risk their lives to improve our X-ray view of the universe.
I can't imagine what it was like in the control room, watching the first light of Chandra and opened its aperture door and actually collect light from the universe for the very first time. When the first X-ray photons actually landed on the detector. Those photons that landed on the detector were the culmination of decades of dreams and the aspirations of many, many hundreds of really brilliant scientists and engineers, and frankly, their families. I can't imagine the emotional relief there must have been when that exquisite image of Cassiopeia A started collecting. You could quite literally see Cass A become populated with these photons. And this absolutely beautiful demonstration of Chandra's spatial resolution, the image that ultimately came down was a completely transformational view of Cassiopeia A.
It was a revolution.
The elements in that star are the same elements on Earth, the same elements in our body, right? It's our oxygen rich and it's iron rich, and these things that are out in the universe, when you see a supernova remnant, that is what life is made of.
This is really the only way that we can peer into the inside of a star, is really by looking at how it explodes and what the stuff that used to make it up does to the surrounding materials. At the same time that there's these beautiful images that every time you look at them, you continue to fuel your own curiosity towards it.
We are on this tiny little planet next to a very ordinary star that's in the middle of its life, in a fairly normal spiral galaxy in some corner of the universe. And the universe is huge, and there are billions and billions of stars and billions of galaxies and supermassive black holes. And yet we are sitting on this Earth And we're able to understand at least some of what we're seeing by just looking.
So there was like totally new science learned in the very first observation of Chandra. I can't imagine what that was like. And when it actually came in, I'm sure there were huge sighs of relief and tears of joy and excitement for the future.
There are moments, I think, where I just feel like the absolute luckiest person in the world because I get to look at this data, look at this information, look at these views of our universe, and it's kind of like having the best seat in this ancient cathedral.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice. A faint sensation, as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. We wish to pursue the truth, no matter where it leads. But to find the truth, we need imagination and skepticism. The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature. The surface of the Earth is the shore of the cosmic ocean. On this shore, we have learned most of what we know. And the water seems inviting. Some part of our being knows this is where we came from. We long to return, and we can, because the cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself. The journey for each of us begins here.
These images portray so much more than what you see on the surface, right? You know, there's information about energy levels and structure and chemical elements in each one of those images that you see, which are so beautiful.
Chandra allows us to directly observe the most extreme events in our universe.
There are jets streaming out from black holes, stretching for thousands of light years into space. There are black holes that can sing a note so deep that no humans can ever hope to hear it.
We didn't know that stars could emit X-rays, for example, and the way they do it. We didn't understand how stars blew up. We didn't understand black holes in nowhere close to as much detail as we do now. We don't understand the clusters of galaxies that make up the web of space-time in the detail that we understand it now. Chandra represents a huge step forward in astronomy in general.
We ask things about what's out there. They help us understand ourselves. When we learn about something there, it tells us about something here. And Chandra has been an incredible workhorse to provide some of that information.
From the furnaces of cosmic change, to the birth and death of stars, to the shining poles of Jupiter, to black holes at the edge of time, and everything in between. You compare what we knew about our universe in 1950 to what we know today, there are multiple cascades of paradigm-changing revolutions that have happened in those intervening decades.
It's hard to convey sometimes that Chandra really is one of the most important astronomical missions in the history of astronomy. It totally changed the way we look at many different phenomena.
I think succeeding in a mission like that is just an amazing feeling. So you then look for the next thing and say, well, we did that, so let's see if we can do more. There are many, many more questions that we need to answer.
There's this common goal at the end, is to getting this mission and answering these really big questions about the universe, right? What we're doing it's really cool stuff. If you stop and think about it, it almost restores the wonder that you had when you were young. You look at these images and they're beautiful and they're captivating, but then you look at what they're conveying and you start to understand the science and you find your sense of wonder again, and you start thinking about, where are we in the universe? How did we get here? How does all this work? And you start asking those big questions again.
What will it mean when you add the power of high energy X-ray studies to gravitational wave studies? And what does that mean for this physics experiment that is the universe? What will those questions even look like? I have no idea. None.
I can't imagine what we're gonna know in 100 years or 50 years, or frankly, what we're gonna know tomorrow. And one of the reasons for that rapid change are the big things that we do in astrophysics, the large missions, right? So Chandra is a real pure distillation of that dream, an extraordinary achievement across multiple dimensions, across multiple decades, across the careers and the lives and the hearts and the blood and sweat and tears of countless individuals, and absolutely one of the greatest missions in scientific history, absolutely hands down.